Hello. Well, balanced binary trees are fairly common in software development. Needing them to be perfectly balanced is not as common. I'm working on a number of algorithms that have one thing in common. They need perfectly balanced data for them to work with full appropriateness. So what I've done is I have worked to create my size-centered tree, which is balancing every node based on the size of the node so that each of its branches has exactly the same number of nodes, possibly off by one if it's an odd number of nodes. The idea of making this sort of tree is a fairly simple idea, but actually making one is quite complicated. And to make those, you do some tests of debugging skills, and you do some of these things like code instrumentation, where you use these nice compiler lines to add in simple log statements that have the glorified name of code instrumentation. And you put those kind of statements, you can see here, all the way through your code. Okay, that's cool. That's cool. Now, it's a little bit nicer if you can easily view that code working. So let's come here where I've got a test tree set up here. Let's turn on my log parent, log left, and log right, just a few of my code instrumentations in this setup. And then we run it, and once it gets running, we will start seeing some of the stuff show up. So let's see, let's start making some stuff, and there, look. There's our code instrumentation. Now, what you saw there for a very brief moment is really what this video is about. This code instrumentation here is cool. There's a lot of information, and frankly, I do a lot more debugging with code instrumentation than a lot of different ways. But with this particular task, it is very nice to have a graphic representation of your tree. So here we've got a tree with a few nodes, and we're able to go around the tree and view the different nodes. And we want to see the data popping in. So let's watch a bunch of nodes come in, and it will automatically look. The data gets sorted. We can visually verify that, yeah, those nodes look balanced. And we would use our code instrumentation to verify that, yes, they were actually balanced. How did I use this really cool structure? So let's see, let's watch it do some stuff, and actually let's turn off this logging since we don't need it now. That logging is throwing a performance curve. Logging takes a lot of processing power. Oh, look at that. Oh, man, look at it blaze away. Awesome. So basically, I use this to find errors in my code. So I was able to get a visual representation to see every single one of these blocks is a node in my code, which represents a piece of data. And you can see these two strings. We've got the purple for the, I think that's the left, and the yellow for the right. So the left node is over here on the purple side, and the right node is here on the yellow side. While developing the perfectly balanced SC tree, size-centered tree, that stands for, the size-centered tree, I was noticing that some nodes were getting accidentally left nameless and unattached as the tree got created. which led to finding the actual bug hidden in the balance code. And so then we were able to fix the balance code and improve the reliability of the code. Now we can see that the code is acting with full reliability. We can now put this tree, which looks beautiful in this representation of it, but we can just put this tree back where it belongs, hidden under the covers where nobody sees it, and it quietly distributes its data in a perfectly balanced format so that the more important algorithms which need that perfectly balanced data can go about and do their business. And then we will move on to our more cool features like star placement and star graphing and A-star algorithms that travel over the stars of an infinite universe and can find locations and all that kind of cool jazz that you can do with game design. Well, it was good talking with you, and I hope you enjoyed this little Starfluke update. Talk to you later. Bye-bye.